Welcome to Math 1300, Nunez Community College. Today we'll be looking at section 5.3, which is logarithm functions and their graphs. In a previous video, we looked at exponents, and we said that if we have y equals b to the power of x, y equals b to the power of x, we said that b was the base and x was the exponent. Well, today we're going to look at rewriting it in a different way, in a different form. This is the exponent form. We're going to look at it writing it in logarithm form. Log for short. Log for short. And the logarithm form would be the exponent is first, x equals log base b of y. That's the way we would say it. X equals log base b of y, where b is the base and x is the exponent. For the first examples, all we're going to do is go from one form to the other and back. So the first form or the first example is going to say, write the exponents as logarithms. Write the exponents as logarithms. And the first one says 2 to the 6th power equals 64. 2 to the 6th power equals 64. So if we want to write this as a logarithm, it would be 6 equals log base 2 of 64. Or if you would like to put the 6 on the other end, it could be log base 2 of 64 equals 6. All we're doing is changing from exponent to log. For the second one, it is 27 to the 1/3 power equals 3. 27 to the 1/3 power equals 3. We want to rewrite it as a logarithm. It's going to be log base 27 of 3 equals 1/3. Log base 27 of 3 equals 1/3. And finally, if I have 6 to the negative 2, 6 to the negative 2 is equal 1 over 36. And I want to rewrite that as a logarithm. It's going to be log base 6 of 1/36 equals negative 2. Again, all we're doing with this first exercise is bringing it from exponent to logarithm form. From exponent to logarithm form. In example number 2, we're going to go backwards. We're going to go from logarithm to exponent. From logarithm to exponent. So we have log base 5 of 125 equals 3. That's what's given to us, and we want to rewrite it as an exponent. As an exponent, it should be 5 to the 3rd power equals 125. 5 to the 3rd power equals 125. Okay, another one that we have might be something like log base 64 of 8. Log base 64 of 8 equals 1/2. Log base 64 of 8 equals 1/2. Well, if I rewrite this as an exponent, it's going to be 64 to the 1/2 power equals 8. 64 to the 1/2 power equals 8. And finally, if I have log base 1/4 of 16, log base 1/4 of 16 equals 2, negative 2. And I want to rewrite this as an exponent. It's going to be 1/4, which is my base, to the negative 2nd power equals 16. And that is going back and forth from logs to exponents and exponents to logs. Okay, in the next example, they want us to actually find the value if given a variable. find the value if given a variable. So if I have log base 5 of 1 equals y, log base 5 of 1 equals y. In order to solve the logarithms, I'm going to rewrite them as exponents. Rewrite them as exponents. And this would be rewritten as 5 to the power of y equals 1. Well, again, as we discussed in another video, anything to the power of 0 equals 1, so we know that y equals 0. Y equals 0. Suppose that we have log base 2 of 8 equals y. Log base 2 of 8 equals y. Again, go ahead and rewrite it as an exponent. And if we rewrite this as an exponent, it's going to be 2 to the power of y equals 8. Well, when solving these things, we have to try to make the bases the same. Because if we can make the bases the same, and both things are equal to each other, then the exponents must also be the same. So I'm going to write this as 2 to the y equals 2, because 8 can be written as a 2, to the third power. 2 times 2 times 2 is 8. And again, once I write the bases the same, and both things are equal to each other, I can then say that the exponents must be the same. So in this case, y equals 3. Y equals 3. And finally, suppose I have log base 7 of 1 over 49 equals y. 1 over 49 equals y. Well, same rules apply. Rewrite it as an exponent. 7 to the power of y equals 1 over 49. Well, I have to try to rewrite them using the same bases. So I'm going to try to write 49 as a base of 7. This will be 7 to the power of y equals 1 over 7 squared. 7 squared equals 49. Now, this is 1 over 7. This is 7 over 1. So what I need to do is I need to rewrite this with 7 in the numerator. So this will be 7 to the y equals 7 to the negative 2. Because from the bottom, I can bring it to the top by writing it as a negative exponent. Therefore, now the bases are the same, so the exponents must be the same. Y equals negative 2. In the next example, we're going to do the same principles, but we're going to have variables in different spots. Variables in different spots. Suppose I have log base A of 32 equals 5. Log base A of 32 equals 5. At this point, it doesn't look like it's something I can write the same bases. But if I change it to an exponent, I got what? A to the 5th power equals 32. So now I'm trying to write the same bases, but I know that this has to be written with a exponent of 5 so that A is equal to whatever base I get. So I want to write it as an exponent of 5. 32 is what to the 5th power? 32 is 2 to the 5th power, as in 2 times 2 times 2 times 2 times 2. So therefore, now with the same logic going on, if the exponents are the same, everything's equal to each other, A must be 2. The bases must be the same. Suppose I have log base 9 of A equals negative 1/2. Well, let's rewrite this, and this would say 9 to the negative 1/2 equals A. Well, negative 1/2, I want to write it as a positive exponent, so it's 1 over 9 to the positive 1/2 equals A. Well, what exactly is a 1/2 power? The 1/2 power is also the square root. 1/2 power represents a square root. 1/3 power would represent the third root. 1/4 power would represent the fourth root. So another way of writing it would be the square root of A, or in this case, the square root of 9. So this would be 1 over the square root of 9. The square root of 9 is 3. So therefore, A equals 1/3. A equals 1/3. And then we have log of 1/2, log base 1/2 of 32 equals A. Log base 1/2 of 32 equals A. Log base 1/2 of 32 equals A. In this case, we have 1/2 to the power of A equals 32, once I change it around. Now, what do we know? I know that this is 1/2, so I'm trying to write the 32 with a base of 2. So this is 1/2 to the power of A equals 2 to the power of what? Well, the power of 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So to the 5th power. Now, this is 1 over 2 is equal to A. So this here, written as a 2, would be 2 to the negative A is equal to 2 to the 5th. In order to bring the 2 to the top. But then we have what? Negative A is equal to 5. So positive A is equal to negative 5. Positive A is equal to negative 5. We then have some logarithm properties, which we're going to get to more in another section, but I think that it's important that we see some of these logarithm properties in order to make sense of how certain answers are becoming popular. So we got the general properties. This is for logs. I'm going to make a chart with 3 different things. So we got the general properties. The first general property says that log base b of b to the power of x is equal to x. Now that's what we have, but if we rewrite it as an exponent, it makes more sense. So if I rewrote this as an exponent, it would be what? B to the power of x equals b to the power of x. So this does make sense. An example would be log base 2 of 2 to the 5th. We would just be able to skip forward and say the answer is 5. Okay. The next property that we have says that log base b of b equals 1. Log base b of b equals 1. Again, when we rewrite this in exponent form, it would be b to the first power equals b. Anything to the first power equals itself. The next one that we have says that log base b of 1 equals 0. And again, if I rewrite this, b to the 0 power equals 1. Anything to the 0 power is 1, no matter what it is. And the last one is b to the log base b of x equals x. This one is written as an exponent. In order to show, we need to write it as a log. This would be log base b of x equals log base b of x. So indeed, that one does work out too. So this is the general log properties. There's 4 of them. And again, if you get something like this, you can just skip forward and give the answer. You can just skip forward and give the answer, and so on and so on. Now on the calculator, we have logs. The logs on the calculator are known as common logs and natural logs. If you look on your calculator, you have a button that is a log button. It just says log. Well, I can't do log with all these different bases. There's no button for me to put log base 2, log base 5, log base 7. So they use a log that's very common, otherwise known as a common log, and that is log base 10. Log base 10. But on the calculator, it just says log. So anytime you hit the log button on the calculator, it's base 10. So these general properties written as common logs would look like this. Log. So remember, it's automatically base 10. So log of 10 to the power of x equals x. So if you come across log of 10 to the whatever this number would be, that would be my answer. In common logs, this would be log of 10 equals 1. In common logs, this one would be log of 1 equals 0. And then finally, in common logs, this would be 10 to the log of x equals x. And then finally, we have something called natural logs. Natural logs is also on the calculator. It should be next to your log button. It should be the number ln. ln, natural log, means log base e. You don't have to know much about it, but e is to logarithms and exponents as pi is to circles. Okay, it's a naturally occurring number. So if you see the number ln, then, and I'm going to be using ln when we're doing logarithms in the actual sections, because natural logs can work pretty much all the time, where common logs work most of the time. So these natural logs with the general properties would be natural log of e to the x, since natural log is log base e. Natural log of e to the x is x. The second one, natural log of e equals 1. The third one, natural log of 1 equals 0. And then finally, e to the natural log of x equals x. This is a reference that you can use because we're going to have some that we're just going to have to simplify, and I'm going to refer back to these properties in order to simplify. And finally, for this section, we have to be able to use our calculator. So we are going to use the calculator to figure some numbers, and they're going to ask us to give us to 4 decimal places. So if we have log of 0.75, you punch the log button, you hit 0.75, and you hit enter. We're rounding to 4 decimal places, and it should come up to approximately negative 0.1249. 1249. Remember to round your last number. And if we have the natural log of 0.669, again, hit the ln button and then 0.669. That should come up to approximately, by the way, I should put squigglies because that means approximately 0.4020, negative 0.4020. Make sure that you can punch those buttons on your calculator so that when you have an actual problem, you will make sure you get the problem right. Okay, well this concludes section 5.3, which is logarithms and their characteristics. I will see you at the next one.